through predicting products in a double displacement reaction. So we're going to look at two examples. The first one, we have barium chloride and sodium sulfide. So we're going to see if we form a precipitate. Our first step is to write out all of the ions that we have. So we have barium, which is an alkaline earth metal, and it will become barium 2+. Chlorine is a halogen, it's -1. Sodium, alkali metal, +1. Sulfur is 2-, it's right under oxygen. Now we're going to predict the products that it makes. So we see that there's going to be a switching that occurs with a double displacement reaction. So we're going to switch the cations and the anions of each. And we're going to try to make products on the other side of the arrow to see what we will get. So the 2 and 2 from barium and sulfur cancel out here. Same thing with sodium chloride. Our next step is to check our solubility table to see what states we're going to get from our products. So to check our solubility table, we are going to look at the anion first. From the anion, we're going to go down all the way to get to sulfur. From sulfur, we're going to read across and we see our cation, barium. We read that it's soluble, so that means that it's able to be dissolved in water. So this is not our precipitate. We're going to look for sodium chloride, and we go all the way down to chlorine. It's not one of those listed, so we circle all others and we go across, it's soluble. Both of these products are aqueous, so that means that we have no reaction happening and we actually don't have to predict any products because our reactants are going to be more stable than our products. In the next example, we're going to do the same steps to see what happens. Number 1, we're going to write out all the ions that we make. So here we have lead nitrate. We see the little 2. We have to reverse crisscross to see that we have lead 2 here, 2+. Nitrate is always -1, potassium +1, sulfur 2-. We're now going to switch our cations and our anions to make new products on the other side. And again, it just so happens that they even out. We have a 2-to-2 ratio and a 1-to-1 ratio for our new products. This won't always happen. So we have potassium nitrate forming and lead sulfide. There's no coefficients because they all cancel out, or no subscript, sorry. Now we also have to check the states with our solubility table. So I'll just get rid of all of our markings from our previous question and we'll start fresh here. We're going to go all the way down to nitrate, go across. The only option is most are soluble, so we know that this is aqueous. Next, we have lead sulfide. We're going to go down to sulfide, check our list. It's not on our list, so we circle all others and we go across low solubility. This means that it does not dissolve in water and it's our precipitate. So we know that this reaction will happen and we need to balance it now that it will happen. So here, let's erase everything. You can go back if you want to review what we did. And we're going to practice balancing. So we're going to write out all of our ions down the middle, all of our atoms. Nitrate is a polyatomic ion, and because it stays together on both sides, we don't have to split it up to nitrogen and oxygen. We have 1 lead, 2 potassium, 1 potassium, 2 nitrate, 1 sulfur. I'm going to put a 2 coefficient here to balance out the potassium and the nitrate, and now we have completed this precipitate reaction. Thank you for watching.